Hello everyone. We're going to understand the organic chemistry. It is one of the enormous branch in the chemistry, which basically deals with the organic substances. So what is organic substances? Pretty much of me, pretty much of every organism in this face of world are made up of organic material, like the emotion or the enzymes, which basically runs us. They are organic substances. So what organic substances is? Organic substances is basically made up of carbon. More specifically, it is made up of hydrocarbon. Okay, so like I'm saying this hydrocarbon, whenever any compound is containing, we call this organic substances. So initially, scientists were thinking that it is not possible to create organic substance because nature create this. So they were believing a kind of hypothetical theory, uh, which we call vital force theory. So they were thinking that any organic substances that comes that we can utilize are basically coming from the nature. So nature create this. It is not possible for human to create any organic substance. But this theory has been proven wrong in the 1828 by a scientist named Frederick Holler. He created urea, which is organic substance. The formula of the urea is CuNH2, or we can write this NH2CONH2. He created this organic substance named urea from an inorganic substance named ammonium cyanate. Sorry, ammonium cyanate. So what he has done, he just heated it up in the laboratory and turned this inorganic substance into organic. So I was saying this organic substance is something which is made up of carbon, but you can see over here this both substance have containing the carbon. So how ammonium cyanate is not an inorganic substance, though urea is. So basically the idea over here is uh, here this one gives any substance which is having hydrocarbon bond. So we can say it is a organic substance. If it is not having, then we can't say it is organic substance. For example, diamond is also made up of carbon bonding. Okay, but we don't call them these kind of like graphite. We don't call them the organic substance because they don't have this hydrocarbon bond. So at least a carbon has to be there. But if you're seeing any hydrocarbon bond in the substance, so we can say it is organic substance. For there is very nice example we can take, which is H2CO3. We call this carbonic acid. Carbonic acid is a very nice example. You can see over here in the carbonic acid, carbon is there and hydrogen is also here. So it has to be organic substance according to the nature of this hydrogen carbon. So we need to check it over here that actually this carbon is attached with the hydrogen or not. So if you see the molecular structure of this carbonic acid, so you're going to find this oxygen, carbon is in the middle of oxygen and this way, and to double bond, and this oxygen is attached with the hydrogen and hydrogen. So you can see this carbon is not actually directly attached with the hydrogen, so we can't say this carbonic acid is an inorganic acid or organic acid, though it contains the hydrogen and carbon, but we can't say this. So we can say organic substances are the substances which contains hydrocarbon bond. Now, why this single substance is making an entire branch in the chemistry, which creates a n numbers of molecules of the compounds? In the organic chemistry, there are 16 into 10 to the power 6 compounds are there, organic compounds, and each year more than thousands of chemicals, the compounds are being added in this branch, and which makes quite enormous. But apart from being enormous, this branch is quite logical and exempt of exemptions, like we have seen in inorganic chemistry. The huge n number of exemptions was there. Okay. Now we're going to understand about the properties of carbon atom, which will make the idea of organic chemistry quite clear. Let's see this one. What is the first property of the carbons? Carbon is tetravalent. They have the tetravalency. Why this carbon is tetravalent? So if you'll see this carbon having the atomic number 6, which in the first shell contains the 2 electron, and the second shell is contain 4 electron. And in order to complete the last shell, carbon needs 4 electron to complete the octet. So carbon is quite electronegative. In the same way, carbon is also electropositive. So it is almost tendency of losing and gaining almost equal, though it is more electronegative than electropositive. And though almost they both of the things are equal, so that's why they create covalent compound. Okay, remember this one because they don't give or entirely 4 electrons or can't take 4 electrons directly because of the less electronegatively. So they ultimately carbon decide to make a covalent compound. So it got the 4 hands. You can see the 4 electrons which is being ready to share in order to make a covalent compound. The carbon makes all type of bonds like double bond. Okay, this double bond or triple bond, even single bond between the carbon-carbon atoms. So that's why it gives the carbon a kind of property of catenation. Catenation. Catenation is the property of element which makes the chain. Basically, catenation it came from the Latin root. The name is catena, which means chain. So carbon is a kind of compound that makes a chain with itself. Like one carbon can attach with another carbon, another carbon, another carbon. In this way, it may be like a straight chain, or it may be a structured chain like this. Okay, it may be cyclic also like this. So carbon got so many way to get attached the another atom, another carbon atom basically, and it may contain oxygen like oxygen, hydro oxide, anything else. But yes, they make the chain with the another carbon like this, and any of them will be having the hydrogen or something. So we can say it is organic uh, substance. Okay, so hope this is clear. So it makes the straight chain sometimes it is a branch we can say, and sometimes cyclic. Okay, because of the property, it has the tendency to form the covalent compounds. So carbon forms this kind of chaining, and this chaining property called catenation. Another substance is also there, which is silicon. Silicon is also having a chain making ability. It can make the chain, but the thing is, silicon can't make more than 8 or 9 atomic chain. In case of carbon, can make n numbers of chain. Okay, so that's a very nice property the carbon has. The carbon makes the biggest chain in the entire element, while the silicon comes in the second, which also makes a catenation property it has, but it can't form a bigger chain than carbon. Okay, then the carbon forms double, triple, and even single bond. So for you kind of information, suppose like there is a 2 carbon is there, and you can see that each carbon having the 4 hands. You can see over there by the Lewis dot structure. If you pay attention closely, here you can see one carbon, 1 electron of each carbon are being shared, so it's going to make like this. But suppose not one electron is being shared, suppose two electron each carbon is sharing in this way, in this way. Okay, so they can create double bond also like this, or they may create a triple bond when the three electrons are being shared. So you can see this carbon having the property of making bonds. It may be the double, it may be the triple, it may be the single, and that is how it led to the creation of different kind of substances. So I'm having some questions for you to solve. So let's start from the question number 1. You can see the first organic compound was synthesized in the laboratory by. There's options: Polar, Cole. Tell me which one is there. So correct answer is Polar. Polar converted this ammonium cyanate into urea. Remember, you must remember the formula NH4CNO. When he heated it up, then this substance converted into CONH2. Okay, this is basically urea. How he converted this urea from ammonium cyanate. So ammonium cyanide, which was inorganic, has been converted into organic. This Kolb also has done the same thing. He has created this acidic acid from the COOH, from the hydrogen, oxygen, and carbon. These substances together, he created this acidic acid in the laboratory in around 1845. Good thing about the Kolb is he actually synthesized. He took the three different material and made it into the organic substance, which is acetic acid. So he was the first one who synthesized in the laboratory, and Kohler just converted down the one inorganic into organic. So that's quite unique. Both of these scientists has done such a nice work that changed the entire perception of the people about the organic substances. Now the next question is, name the first organic compound which is obtained from an inorganic compound with the formula. So we have already have given the answer of this question. You can see the first organic compound is urea, that we got it from the ammonium cyanide. So you can see this is the answer already done. Now we're going to move to the next question. Which of the following is not an organic acid? Ethanoic, formic, citric acid, or carbonic acid? So all of them are the organic acid except carbonic acid, as we have discussed. This carbonic acid is not an organic acid. Is not an organic acid because you have seen this carbon is actually attached with the oxygen in this way, and this oxygen is attached with the hydrogen. So that's why there is no direct bond between the hydrogen and carbon. So the carbonic acid is not an organic acid. Next question, the main source of the organic compound is, so the main source is coal tar and petroleum. Okay, so these answer has to be C. Now you should answer this question. Name the element other than the carbon which exhibit the property of catenation in the comment box. Thank you so much. We will meet you in the next lecture where we will discuss about the hydrocarbons, types of the hydrocarbons, and we will also try to understand how we can name the organic substances.